here. Okay, so let's talk here for just a couple of minutes about this situation. So 8.1, we talked about right triangles, right? And that was really nice because we've been in the unit circle this whole class, and the unit circle is made up of an infinite amount of right triangles. So we got to use Pythagorean theorem. We got to use SOHCAHTOA with the opposite and the adjacent and the hypotenuse and all that good stuff, right? Well, as you probably know, there aren't just right triangles in the world. There are other kind of, strange little wonky triangles in the world. So we call those triangles oblique. All right. Now, this is not, you're not going to have a vocabulary test, but I just want to kind of make sure that you understand these words because it does help on your SAT and your ACT. Now, don't confuse oblique with obtuse. Okay. Two different O words. Oblique just means not a right triangle. That's all that means. Not a right triangle. Okay. So an oblique can never have a right triangle because that's its definition, which leads us to the fact there are two other triangles in the whole world. There's only three. One's a right. The other two are ones that have three little acute angles, right? All their angles are less than 90 degrees. The other kind of triangle is way wonkier. So this one's kind of like a cute little triangle that like a little kid would draw, right? Like a regular little triangle, kind of like what's on the board. Okay. This crazy triangle here says you have two acute angles that are tiny and one obtuse angle. So an obtuse angle here is between 90 and 180. So he's big, really big. So that might kind of look like something like this, one of those kind of triangles, right? You got a little cute angle and a little cute angle, and then you got this guy here, which is obviously bigger than 90. He's not all the way 180, but he's bigger than 90. He's like leaned back in his chair, right? So two types. Well, not for these. The other type, the third type would be a right triangle. You got three types. Yes, yeah, anything bigger than 90, but not 180. Good. Okay. Now, since we're focusing on these two and we don't have a right angle, no more Pythagorean, no more SOHCAHTOA. Because remember, SOHCAHTOA is based on Pythagorean theorem. It uses words like opposite, adjacent, hypotenuse. There's only a hypotenuse if you have a right angle. If you don't have a right angle, there's no such thing as those three. So I can't use those here. I need another tool, okay? Well, don't forget, this guy's always gonna come in handy. All triangles, no matter how crazy, all their angles are gonna sum to 180. So that is still available to us and it always will be, which is fantastic. We're gonna use that a lot, okay? But there are four types of oblique triangles, okay? Four cases, I should say, because there's only two types, but four cases in the sense of the information they give you, okay? Four little pieces of information. So one would be if they give you one side and two angles, okay? So that could be one side that's not next to the two angles, that's not in between the two angles, or it could be a side in between the two angles given. And what I mean by that is if you have a triangle like this, okay, let's say they give you this angle and this angle, they might give you one of these sides over here, or they might give you the side in between, right? That's a choice. That's a possible case, okay? They might give you two sides and one angle not included between the two sides. That is this situation. Now we spell it that way. We spell it SSA because, heaven forbid you guys have to deal with a dirty word, but I'll be honest with you. It ought to be the other way because this really true. This case is a real, it really just turns out that way. It's a pain in the you-know-what, right? And here's why, because it's the ambiguous case. This is the ambiguous case. When you are given two sides and a non-included angle, so it spells out this dirty word, you got some work to do. It's unfortunate. It's a pain in the butt. Okay, literally, right? You may have one triangle you may not even have a triangle. The information they give you may not even make a triangle. Or it may be able to make two triangles. So that's why they call it the ambiguous case. Ambiguous just means like kind of fuzzy, kind of I'm not real sure, unknown, right? Okay, so this guy is difficult. We got to keep our eye on him. This is actually my math lab number 3. It's going to talk about how do you make an ambiguous case, and then you'd have to, you have to spell it SSA. They won't let you write ASS, but we know that's what it means. This is paying attention all of a sudden. Okay. Okay. So here's 100. Okay. All right. Cases 3 and 4. 3 would be two sides with the angle in the middle. See, it's different than this one. This angle is not included between the two given sides. This one is. And then case 4 is that you have 3 sides given. You aren't even given any angles. You're just given side, side, side. Okay. All right. So 4 possible ways to get information to you. Notice they all involve at least one side, right? They don't all involve an angle, but they have to give you at least one side. That's super important. Okay, so we're going to split up these cases into 2 sections. So today we're going to cover these 2 cases with the law of sines. Okay, that's what we're going to cover today. All right, tomorrow we're going to cover these 2 cases. They're going to be the law of cosines. Okay, this is actually my math lab number 2, is that if you're given 3 sides, you can solve the triangle. You just have to use law of cosines to do it. So that's my math lab number 2. Number 1's on the next page. Okay, so some classes get real caught up in wanting you to name, like, given side angle side, what do you use to solve? Don't get hung up on these letters. Don't get hung up on, you got to have this to solve this and this to solve this. It's not necessary, okay? This is what you want to solve with, the law of sines. That's what we're going to cover today. It's the easiest. If you can't, then you go here. You would never start here unless you have to. And that's what we'll talk about tomorrow, because the math is more complicated. So it's kind of like, no matter what you're given, you're always going to start with the law of sines. Then if you can't use it, you switch to law of cosines. That's kind of the rule, all right? The only little letters you have to remember, and everybody remembers it because I told you it's a dirty word backwards, is this guy, right? If you end up with the SSA or the ASS case, then we're going to have to take certain steps that we ordinarily wouldn't have to take. Other than that, we're going to try law of sines, and if it works, fantastic. And if it doesn't, we switch to law of cosines, and then we got it all solved. Okay. All right. So let's talk about this ambiguous case. Just a minute. How on earth could you suddenly get 2 triangles? Okay. I'm going to do my handy dandy ribbon demonstration. I went in Abby's room and woke her up last night and fished this out of a drawer. Okay. So anyway, let's say this is our triangle. Okay. They're not going to give you all of this, right? They give you one side, and then in the ASS situation, they give you one angle and 2 sides. So they're going to give you this side, okay? And then they're going to give you this angle. I'm sorry, actually, let me change that. I think they normally give you this one, okay? And then they give you this one. Okay, that's normally what they give you. All right, and then they want to know, does this make 0, 1, or 2 triangles? Okay, well, if this side is too long and comes all, this is set, right? This angle is set, and this side is set. If this side they give you is too long, there's no way for it to make a triangle if it's down here. No way at all. Because if this is set, it would have to make a bigger angle to come down here, and you can't, right? If this side ends way down here, how are you going to get this to meet here? You can't do that. And even if you could, you would have to change the angle, but it's already been given, and you can't do that. So it's not good. Sometimes what they give you does not even make a triangle. Does that make sense? Sometimes this side is too long. And if it's too long, then these don't fit, okay? And then if you go through and solve it, what you'll find is this one's too short. It doesn't make a triangle, all right? Sometimes what they give you is perfect, makes a triangle. And sometimes what they give you could make two. So if this is how long this side is, that's fantastic. We made a triangle. But couldn't we also make another one? What if we swung this side over here? Sorry, summer. But look what I made here. I made one of those wonky little obtuse triangles. See it right there? That's totally a triangle right here. And then this is totally a triangle here. So sometimes the side they give you, if you leave it like this, that's fine. But what else can you do? You could swing it this way, and then you have two triangles stuck inside one. And so by swinging it that other direction, you find that you've got this triangle and you've got this triangle given the information. And when that happens, you have to solve for this one and you have to solve for that one. You have to solve for both. Does that make sense, kind of? So you never know in this situation if this is going to be too long, causing this to be too short and it doesn't work, or if it's all perfect and makes one, or if the situation comes together just right, where this is just long enough and this is just long enough and this is the perfect angle that you could swing this side inward, and suddenly there's two triangles inside the one. So that's why, given side angle, right, we have to check. Does that make sense? A little bit? Okay, if it doesn't, it's okay. Just know if you come up with a dirty word, you gotta check, but there you go. All right, so let's go on then to our next page. Let's jump right in. Okay, so what in the world is the law of sines? Okay, law of sines is on our next page. Okay, this is the law of sines. Okay, here we go. The law of sines is super easy to use. We always want to use it. Students, I mean, you may want to write this on your index card come Friday, but you're going to remember it, I promise. But basically, it's just a bunch of proportions. It's three little proportions. And what it says is that the side of A divided by the sine of his angle equals the side B divided by the sine of his angle, which also equals side C divided by the sine of his angle. Now, I'm sure you realize you can't have two equal signs in anything. So we're not going to use all three pieces. You're going to choose the two pieces that work for you in each problem, okay? You're going to choose one piece that you have all the information for, and then you're going to choose the other piece that you have one piece of the information for. It could be these two, the ones on the end. You can choose any two pieces you want. If it makes it easier, you could even flip the whole thing. And look at here, we just took the bottoms and put them in the top, and we put the sides in the bottom. You could use this form if it makes it easier for you to solve. This alternate form is actually my math lab number 1, okay? Just showing that you can flip it if you want to. All right, so again, you're gonna pick two, choose one you have all the information for, choose the second one that you have one piece of information for, because as you know, we can only have one missing item. That's it, okay? This is why you might flip. If you're looking for a side, choose this one where the sides are on top. If you're looking for an angle, choose this one where the angles are on top. It doesn't really matter, but it'll make your math so much easier. It makes it much, much easier in terms of math, but it's not a deal breaker by any means, okay? All right, and then we also want to just remember this, we talked about this already, that your smallest angle is across from your shortest side. largest angle across from your largest side. Remember that little piece of information we talked about just to make sure everything works nicely. Okay. All right, let's jump right in, page 11. Okay, so I went ahead and drew you some triangles. I'm like so boring. I draw the same stupid triangle for every problem. Even when it's obvious that is not the triangle, I still draw it. So I'm sorry, but I was trying to be helpful, but the angles are going to be the same for whatever. I just throw them on there. All right, so let me talk about what they give you. Sometimes they'll go ahead and give you letters. Now the letters won't be standard labeling. They love to just throw letters in there. So what if what they give you is they tell you this is A, they tell you this is B, okay, and then they leave it alone and tell you that. Oh, and they give you a 9 down here, okay? So what if this was the picture and the information that they gave you? Okay, well, what side is 9? C, because it's the only one left not labeled. So what does his angle have to be? C, right? C. Okay, so here we go. We're going to solve the triangle. We need all the angles and all the sides. All right, well, first thing I notice is I can totally fill in A, right? I don't even need anything special because I know all the angles add up to be 180. Okay, so 180 minus 100 is 80, minus 60 is 20. So there we go. That was easy enough. Okay, now this is not a right triangle. There is not a 90 degree in sight. So no Pythagorean, no SOHCAHTOA. Okay, that means we then go to law of sines. Okay, now we have to decide which law of sines do we want. Okay, well, remember we said we want to choose one that we have all the information for, meaning the side and the angle. Well, there's only one letter that I have all the information for. Who would that be? C. I have all the information for C. So I'm going to take, and I know I have to solve for a side. Everybody agree with that? The sides are the only thing missing. So I'm going to use this version up here where the sides are on top, and I'm going to go ahead and choose C, okay, because I have all the information for him. Now I need to choose my second proportion, and this one's up to you because I have B's angle and I also have A's angle. So it really doesn't matter which one you choose. I mean, they gave us B, so we could use that just to be really super correct in case we subtracted wrong, but Ish is yelling do A, so we could be a rebel and do A. Okay, we don't know. Okay, so does everybody see where we got these two from? Does that make sense? We can't use B and A. Why couldn't we use B and A together? Because I don't know side B or side A. I have to use one where we know everything. Then you can choose the other one where you're missing one. Okay, so little c, side C is 9. Angle is 100. I don't know side A. Sine A. There we go. So I just filled in my information. So again, your goal is to only have one letter left that's unknown. If I use B and A together, I'll have 2 letters that I don't know, and then I can't solve it. Does that make sense? But I could have used C and B if you wanted. That would have been fine. All right. So I want side A. So now I'm just going to cross multiply. Remember back in the day in elementary school when you had one chunk equals one chunk? You just cross multiply. And that's how you find the answer. Okay, so I'm going to do 9 times the sine of 20 degrees equals A times the sine of 100 degrees. And then I'm going to divide by sine of 100 degrees. And that's going to give me A. Okay, does everybody see how I did that? I just did 9 times the sine of 20, A times the sine of 100. That's all I did. And then I set it up across from each other. Okay, so here we go. I'm going to put it in my calculator. I have it in degree mode. I'm going to do 9 times the sine of 20 divided by the sine of 100. And it turns out A is 3.13. And there we go. Is everybody okay how I did that? I just cross multiplied. Now, you don't actually have to write this out. Let's think about what I did. Okay, because here's the quick and dirty step that's going to save you time. All right, I'm going to cross multiply. I'm going to multiply together the ones that I know. So 9 times sine of 20, and I'm going to hit enter. Then I divide by the other, the one on the bottom over here. And that's going to give me my answer. So I never actually write this out. I just do 9 times sine of 20 equals divided by sine of 100. And that gives me A. Is that okay? Ish, did you have a question?
Yeah.
Okay.
Is that it? Or...
Yeah, there's your A.
Oh,
Yeah.
We check it now?
Well, now we got to find B.
Oh, okay.
Now we got to find B. Okay. Is everybody okay how we found A? Okay. Now, I can't use Pythagorean to come up with B, right? I'm going to have to do this again using B. Okay. Now, I don't want to use this A that I just found, because what if I'm wrong? Then I'll get B wrong also. So I'm going to stick with the C that I already know because it was given to me. Okay. And now I'm going to set it up with side B over sine of 60, because that's angle B. Is everybody okay with that? I just put little b over sine of B. Okay, if I want to, I can cross multiply and set it up just like this. Otherwise, I can do, and this is only because my unknown is on top, 9 times the sine of 60. It's going to be a little more complicated because the one unknown is on the bottom. Then I'm going to do, hold on, I did weird stuff. Divided by, hold on, it got even weirder. Sine of 100. And my B is 7.91. So I multiplied here the 2 that I had, divided by the one that was still on the bottom. And B is 7.91. And there we go, I'm done. You solved it. And you also had this angle here. Okay, how's that sound? Not too bad? It's pretty easy stuff. It's really not a big deal. Okay, ready to go to the next one? You don't. There's no real way to check it other than to just really be very careful in how you do it.
Math doesn't, if you did 9 divided by sine and B divided by 60, wouldn't it be equal?
Say that one more time. Oh, you mean on this side and this side?
Yeah.
To see if they're equal? Oh, you could do that. Yeah,
And that's
yeah.
how you check it?
Yeah, you could, but I mean, you created that. But yeah, but you could if that makes you feel better.
Okay.
Yeah. He's saying, what if I did 9 divided by, hold on, I speak ish. Give me a second. 9 divided by sine over 100. Okay, he's saying that's what this one equals. Let's check this proportion and see if it's right. So this side would be 7.91 divided by sine of 60. And then look, those are the same, you know, pretty much 9.14, 9.13. You're going to be off a little bit because you're rounding in here, but pretty darn close, right? So that's, if you want to do that, you can. Keep in mind though, you set up that proportion. So if you set it up wrong, you know. Okay. All right, here we go. Example 2. Let's see, what do they give you here? They're going to give you 43 degrees in the top. And they're going to tell you this is A. And they're going to tell you this is 76 degrees. And they're going to tell you this is B, this is C, this is 12. That's what they're going to give you. And by the way, I should have pointed it out. How did we know example 1 wasn't that ambiguous case? That was a pain in the butt. We should have gone back and looked at that. So remember, the ambiguous case gives us this situation, right? Okay, here's what was given to us. We were given those two and this. We were given angle, angle, side. See that? We weren't given angle, side, side. So it's not ambiguous. We just solved with what we had. Okay, so we were good to go. Okay, let's check down here. What are we given? We're given angle, side, angle. A. So we're good. Okay, so we're still not the dirty word. So we're able to keep going. All right, let's finish labeling this. What is this top one going to be with the 43 degrees? C. Good. And B will be over here. And this little 12 is going to be A. Okay. First thing I always like to do is if I have two angles, find the other one. So angle A, remember, is going to be 180 minus 43 minus 76. That's going to give us angle A. I came up with 61. Okay, that's my angle A. All right, now that I've done that, I'm going to do law of sines because it's easier. Okay, well, my first proportion has to be the proportion where I know everything. So for what letter do I know the side and the angle? A. Perfect. Okay. Then I also check because I need to know who's going to go on top. I'm solving for sides. So I'm going to put my side on top. Okay. All right. Now I need side B and I need side C. It doesn't matter which one you start with. If you want to go in alphabetical order, let's do B. Okay. So these are the two proportions we're going to use. You have to use A. But you could have chosen C instead over here if you wanted to do that. All right, let's fill them in. So there's a 12 over sine of 61 degrees. We don't know side B, but we do know angle B is 76 degrees. There we go. Okay, we put what we wanted to find on the top. Now we can multiply these two sides together and divide by sine of 61. Okay, so I'm going to do 12 times sine of 76 divided by the sine of 61. Don't forget, you have to be in degree mode for this whole chapter. Okay, and I get a nice little B of 13.31. There we go. Okay, now I need to find C. Can I use Pythagorean? I know two sides, I need the third. No, it's not a right angle. There's no hypotenuse. Okay, that means we got to do this again. You could use the B's now that you know it, but I strongly, suggest against it because if this is wrong, then you're going to get C wrong. I would stay with A because you know those are right. Whoops, I wrote the wrong thing. Okay. Sine of 43 degrees. Okay. So again, we're going to multiply 12 times sine of 43, divide by sine of 61. You should get 9.36 as your C. And then if, like Ish said, if you want to plug those in and just make sure each side is equal, you could do that if you want to. Did everybody get this okay? All right, you put in degree mode, you know how to multiply, you know how to divide on those, you're good? Okay. All right, let's try two more. Let's see, we may not even need to do the two more. Let's see. How are you guys feeling if we just talk about number 3 and then we do number 4, just to skip one because of time so that we can get to the ambiguous case? Is everybody okay with that? All right, let's just at least set these up. Okay, for example 3, we'll just set it up and then we'll do example 4. Okay, so hold on, my McAfee decided to stand. Okay, it says solve the following triangle. It doesn't even give you a triangle, so I didn't give you one. Okay, but it gave you some information. All right, so again, I have angle, side, or let's just at least draw our triangle. Like I said, I always draw the same stupid triangle. Maybe you guys want to be a little more precise. Okay, you can put these in any direction that you want to, really. What they usually do with these oblique ones is they do it this way. I know that's kind of the opposite of what we did with right triangles. It really doesn't matter as long as you label the sides correctly. Okay. All right, so this is 30 degrees with a side of 5 for B, and C is 50 degrees. Okay, so we're going to have angle, angle, side. Okay, not that it matters, but we just know it's not the ASS case, right? That's all that matters, is it's not that one. All right, so then you would, what would be your first step that you would want to do here? You got to find A, because well, you don't have to find A, because look, you have all your information for B. You could find side C if you wanted to, or you could find angle A. How would I find angle A? 180 minus 50 minus 30. Your angle A is going to end up being 100 degrees. Okay. So then you could use your B's or the B's are the only ones you can use. And you're trying to find a side. So 5 over sine of 30 degrees. I'm just using my B because it's the only one I have everything for. And then you can decide, do you want to find A first or do you want to find C first? That's up to you. I'm going to go ahead and give you the answers. C is 7.66. A is 9.85. Okay. But as long as you set it up and you realize you have to use the proportion that gives you all the information first, then you can pick whichever other one you want. Okay, let's talk about triangles for a minute here. I forgot to mention this on the first page here. Okay, anybody know, we're talking about angles and sides and how they relate. What do you call a triangle where all the sides are the same? Anybody remember what that's called, where all the sides are the same? Close. It sounds a lot like equal. There we go. It's an equilateral. If all three sides are the same, it's called equilateral. If all three sides are exactly the same, what's the relationship between the angles? They're all the same too. Okay, now let's go back to isosceles. Okay, isosceles means that two sides are the same. Two sides are the same. One is not, but two are. Equilateral, all three are. Okay, so if these two sides are the same, okay, these two sides are the same, what can be said about their angles? They're the same too. Okay, if two sides are the same, then the two corresponding angles are the same. Okay, let's take a little peek at this guy down here then. All right, you don't have to know that piece of information, but it saves you a step if you know it. Two or more triangles? It's usually just the two, and equilateral is the three. But maybe technically that's true, and then equilateral would be a special case of isosceles. I'm really not the geometry expert. Yeah. Okay. Okay. You're done. Okay. So insulting my triangles. All right. Okay. All right. So when I see this, I automatically think, oh, angle A and angle B are the same. Well, guess what? Side A is going to equal side B. So if I find one, do I have to find the other? No, not unless you really, really want to. I mean, on a test, I probably would, but on like my math lab or something, I wouldn't. I throw it in. Okay. All right. So I'll try not to draw the stupid same triangle every time. Since I know he's isosceles, that's how I always draw an isosceles. I just make them look like that. Okay. And then you can label this any way you want, but usually with an oblique, they do it this way. Okay. So I'm going to say he's 20 degrees. He's 20 degrees. And he's 4. Okay. I like to check and make sure I don't have an ASS situation. I don't. I actually have an angle side angle, right? My side's included between the two angles. So I'm good. All right. How do I find this third angle up here? 180 minus, right? Okay. He's going to be 140. I don't know if I can squeeze in 140, maybe I can. Yeah, okay. All right, so now when I choose my law of sine proportions, what letter has everything? C. So I'm definitely choosing C. And again, I'm going to put side C on top because I'm finding the other sides. Okay, and then you can just choose. Do you want to find side A or do you want to find side B? Okay, here's our side A. So there's our little proportion. I'm going to fill it in. I got a 4 over the sine of 140 degrees equals A over, oops, sine of 20 degrees. Oh, let me just show you something. Did you guys see what I just did? Probably not because you were writing. I did A over 20 degrees because I forgot to put the sign in. That is the most common mistake, is that students, they get those angles in, but they forget to put the word in. And then you just do 4 times 20 and it's going to mess it up. Make sure you have a sign for each one of those angles. You don't just put the degrees. Okay, so we're going to do 4 times sine of 20 divided by sine of 140. And our A is 2.13. If you want to, you can set this proportion up for B, or what is B going to be? 2.13, because we noticed it was isosceles, so those sides have to be the same since their angles were the same. Sound pretty good? Okay. All right, well, I think we've done those to death. Let's move on to the ambiguous case. Okay. All right, the good old SSA. Okay, so strange situation occurs. We already talked about this. We may get a triangle, fantastic. We may not get a triangle at all. Or the given measurements may produce 2 with 2 different sets of measurements. So we never know. So when you are given information, check and see, is it an ASS? If it is, you need to take precautions and think about things because it may not come up the way you want. Okay, so let's go through every possible case. First, let's look at no triangle exists. Okay, spoiler alert, that's what's going to happen here. Okay, well, it appears completely normal, right? 2 sides, we have an angle. Okay, no big deal. I'm going to draw myself a nice triangle. It's the same stupid triangle I draw on every one. Okay, here's A, here's B, here's C. All right, let's fill in our information. Side A is 8, side B is 10, angle A is 70. This is when I realize, right, that I have angle side side, or side side angle. That's when I realized this could be an issue, right? Okay, so all that means is we just have to be vigilant. Okay, we just have to be vigilant. Just be aware. All right, so we're going to do law of sines. I can't find angle C and B because I only have one angle. So I can't do 180 minus anything, right? So I'm jumping right in. So what letter has everything? A. Okay, now be careful here. We've been writing side A on top every time. So I notice I'm going to be using A. What's the other letter I'm going to be using? B, because it's the only one that I know something about. Does that make sense? What am I going to be solving for B? The angle. So we're going to need to put our angle on top this time to help us figure it out. Okay. So this is the one we're using. We know everything about A. We know one piece of B, and we're solving for angle B. So we're going to put our angle on top. Okay. So here we go. We're going to fill it in. Sine of 70 degrees over 8 equals sine of B over 10. Okay. Now we're going to do the same thing that we did, except the answer we find is not going to be the final answer. Okay, because it's not like we have one little item here. We have sine B here. So what we find is going to be equal to sine B. And then we're going to have to take sine inverse to find the angle. Does that make sense? Because remember, if you don't know an angle, you have to do inverse. So we're going to do 10 times 70 degrees. I always like to do the side first and then the angle last. So 10 times sine of 70, okay, divided by 8. I get 1.17. Okay, everybody okay with that? All right, now that's not our answer. That's not what B is. Remember, when you don't know the angle, but you have the value, remember what you have to do? Sine inverse. That's going to give you angle B, sine inverse. Okay, some of you already did it and you're looking at me like, what in the world? Okay, so if I do second sine 1.17, what happened? Error. What does that mean when your calculator tells you error? It's undefined. It's undefined. So when you get an undefined, that means there's no triangle. There's no triangle. Now, if you were really vigilant, you would have known there wasn't a triangle right here at this point. Why is that? Why can't sine ever be 1.17? Because whether or not you're on the unit circle or not, sine is bound between -1 and 1. So if sine is smaller than -1 or bigger than 1, it's undefined. It's not even possible. So if you're really with it, you would have stopped here. But you can always plug it in. And as soon as you get undefined, it's going to tell you those measurements aren't even possible. There's no way a triangle exists. And so when that happens, there you go. So a couple things to remember. Put your angle on top with the ASS case, right? It's just another reason this thing's a pain in the butt. Okay, got to put your angle on top. You got to have to do the inverse sine. And when you do it, you'll be undefined and you know there's no triangle. Okay, so what tells you the triangle does not exist? Well, the undefined, right? Or the error, you know, whatever. Okay, let's look at the other two choices. All right, let's look at what happens when two triangles exist. Okay. And by the way, these are kind of all mixed up in examples 8, 9, and 10. I didn't give you the My Math Labs, I'm sorry about that, but you know, 1, 2, and 3 were kind of in the beginning information. And then example 1 was 4. Example 2 was 5. Example 3 is 6. And example 4 is 7. And then 8, 9, 10 are all with the ambiguous case. You'll have one of each situation. Okay. All right. So here we go. Again, you're not going to know this is ambiguous. You're going to have to realize it when you draw the triangle. Okay. So let's say we draw the triangle. Here we go. All right. Now I'm going to label him kind of weird just because I want him to match the triangle I had on the board. And given the information we have, this is how that would happen. But you don't have to do it that way. You can do it any way you want. Okay, so this side is 9. This side is 11. And I have 20 degrees here. Okay. All right. So I notice I have angle side side. I'm on high alert. This could be this is an ambiguous case. I could have 0, 1, or 2 triangles. All right. So first thing I know is I have everything for B. So I'm definitely going to use B. I have one item for C, which means I'm going to be solving for angle C. So who's going to go on top? The angles, the sine. Okay. So I'm going to use sine B over little b equals sine C over little c. Okay. All right, I'm going to have sine of 20 degrees over 9 equals sine C over 11. Okay. Sorry, this is focusing on weird. There it goes. Sorry, Sam. Okay. All right, so, okay, now we're going to solve this and we're going to solve for sine C. That's what we're going to end up with. Don't forget that. So I'm going to do 11 times the sine of 20. Okay, let me see if I can get this to focus so you both can see it. There we go. Okay, so 11 times sine of 20 divided by divided by 9. Okay, and I get 0.418. Okay, now remember, that's not angle C. How do I get angle C? Inverse of that answer. So I'm going to do second sine of 0.418. That gives me 24.7 degrees. Okay. That's C. So this immediately tells me I at least have one triangle, right? This is the point where if you didn't have a triangle, you would get undefined and then you would write no triangle. So I know I at least have one. Moving along. Okay, there we go. All right, so at least one exists. Got at least one triangle. Okay, now what we can do is we can go ahead and solve for everything dealing with this one triangle, and then we can test for a second, or we can jump right in and test for a second. I like to go ahead and finish the one we have, and then we'll test for a second if there is one. Is that okay with everybody if we do that? Okay, so this tells me that angle C is 24.7. Okay, now how am I going to find angle A? Yeah, I'm going to do the good old 180 minus 20 minus 24.7. Okay, that's going to give me, let's see, 135.3 degrees. There's angle A. Here's angle C. Okay. The only thing left to find then is what? Side A. Okay, so the only way we're going to find side A is to do another law of sine. Does everybody see that? Okay, so if I'm solving for a side, who's going to be on top? The sides, right? So now I'm going to have to kind of switch my order. Whatever I want, I put on top because your math is a lot easier that way. So I'm going to be solving for side A. You could use B or C. I'm going to use B as the one that has all the information because that's what they gave me. And that way, at least I have a fighting chance of getting A right. Okay. So I'm going to use the other way now, and I'm going to use the sides on top. Does everybody see why I had to change that? I used this one originally, but now I went here because that's what I'm trying to find. So I'm going to have 9 over sine of 20 equals little a over sine of 135.3 degrees. Okay, I'm going to do 9 times sine of 135.3 divided by sine of 20. And I get an A of 18.51. And there, I solved the whole thing. I did it. Okay. All right, so that was my one triangle. Now, because it's an ASS, I now have to check for a second triangle. Okay, let's talk about how to do that. How do you check for a second triangle? Okay, your first step is you're going to do 180 degrees minus the first angle solved for above. Okay, we'll talk about why and what all this means in just a second. Okay, all right, second step, you're going to do 180 minus the given angle from the problem minus the answer from number 1. If that ends up coming up positive, you have a second triangle. If it's negative, you don't. That's how it works. Okay, so if the answer to number 2 is positive, you have a second triangle. If the answer to number 2 is negative, you don't, and you're done. You already solved for the first one. Okay, so let's talk about why these are the steps, just in case you want to know. Okay, some of you are just, that's fine with me, I believe you. Some of you are like, well, kind of why? All right, so why are we taking 180 minus the first angle we solved for? And by the way, this was the first angle we solved for, if you recall. This is the first thing we did. So I'm going to take 180 minus this, okay? The reason I'm doing that is to see if there's still room in there for a second triangle. Remember, all triangles add up to be 180, all right? And you can't have an angle for a triangle bigger than 180, right? A triangle angle, even if it's obtuse, can't be bigger than 180. So you're checking here to see, is there room? Is there going to be could we get a positive angle from the 180 here using this? Okay, when I subtract that, I get 155.3 degrees. I'm going to call this C2. This was C1 from triangle 1. I'm just going to do that so we're just not totally confused, okay? Now that I kind of have this alternate possible universe where a second triangle exists, I'm now going to take 180 minus the given angle, which if we go back up here, you can't see it on mine, but if you look up top, remember B was 20. Remember that? You were given B is 20. So this is given information from the original problem. Here, I'll show you. Right here, right? It was given. That's where I got that from. Okay. Minus the answer from number 1, which is 155.3. Okay, so this is C for the second triangle. We were given B, so this would be angle A for the second triangle. If he comes out positive, you have a second triangle. If he's negative, you don't. So when I do this, it turns out, sure enough, he's tiny, but he is an angle. So we have a second triangle. Okay, that's how it works. So those are your 2 steps. That would be something I recommend putting on your index card. This 180 minus the first angle that you solved for is because an angle in a triangle cannot be bigger than 180. This 180 is because all the angles in the triangle have to add up to be 180. It's unfortunate that they're the same. You're testing for 2 different things here, but the 180 is really confusing because students think you're doing the same thing over and over, okay? But this is what you do every single time. 180 minus the first one that you saw 4 above, then 180 minus the given angle minus the number 1 answer. If it's positive, you got a second triangle. If it's negative, you just have 1. So what that means is over here, I swung my ribbon around and here we are. The 20 stays the same. The 9 stays the same. This length, though, has been cut. The whole thing does equal 11, but this is for one triangle. This is for another triangle. We found out this little angle, of course, it's terrible. I have them switched, but one is 4.7 degrees and one is 155.3 degrees. Okay, so I'm not quite done here. All right, so for my second triangle, I have C2 and I have angle A2. Now I need little a. All right, so if I need little a, I'm going to put little a on top, sine of angle A on the bottom. Okay, I'm going to use my B information that was given to me just so that I don't, mess anything up. You can always use what's given to you. It never changes. When I multiply 9 times sine of 4.7 divided by sine of 20, I get a little a of 2.16. If you want to call him A2, you can. You don't have to. I just kind of made up those numbers for the A2, A1, all that if you don't want to. So what tells you that 2 triangles exist? This, right? That this is positive. This step 2 is positive. Okay. I know that's super weird. That's going to have to come with practice. All right. So again, if this one up here that you solved for, your first angle that you solved for, if he's a legitimate angle and not undefined, you have at least 1 triangle. Finish him off. Then make a little area for yourself and do 180 minus him. And then 180 minus the given minus what you got here. And if that's positive, you have a second triangle. And if it's negative, you don't. Okay, is everyone okay with that? It's kind of crazy and involved, but there it is. Okay, so we looked at no triangle and we looked at two triangles. Let's look at one triangle. Okay, we'll look at one triangle. And then we just have 3 word problems that I'll probably have to record for you, unfortunately, and send them to you, but you can just fast forward to the point where, you know, mine start. Okay, so let's look at one triangle. Okay, again, there's no way for you to know that only one triangle exists. So we need to make ourselves a triangle. Here we go. There's my same little triangle. Okay. All right. All right, I'm gonna do, let's see. What did I do for the other one? You can label these any way you want. It doesn't really matter. I keep labeling them different ways because my math lab keeps labeling them different ways. So I'm just trying to match them up for you the way they would do it. They're just not real great with standard labeling, but it doesn't really matter. Okay, side B is 5. Okay, side A is 7, and angle A is 70 degrees. I check for the ambiguous case. I have angle side side. Yep, okay, we got an issue. All right, well, here we go. Gonna use law of sines. Who do I have all the information for? A. I got one little piece of information for B, and I'm gonna be solving for his angle. So put your angles on top. Angles always go on top for ambiguous case. Okay, so I'm gonna have sine of 70 degrees over 7 equals sine B over 5. Okay. All right, so again, I'm going to do 5 times the sine of 70 divided by 7. Now that's not giving me B. Remember, that's just sine B. That's going to be 0.6712. Now, again, make sure you guys know you can always do this on the calculator. You can just copy your answer. So if I do 5 times sine of 70 divided by 7, and then remember, I know I'm going to have to hit inverse sine. So if I do second sine, okay, some of you are able to go right back up here and copy your answer. And then there's your angle. You can go right back up there and hit it. Some of you, depending on your calculator, especially if it's older, you're not able to do that. So let's look at what you would do just to save yourself some time. Okay, so if this is where you are and you want to hit second sine and you can't go back up, some of you just can't. See this little, well, no, you can't see it, sorry. Right above the negative in blue, it says A and S. That's your answer. You can always do second negative and it puts your answer in there. It's the same thing. It just transfers up into there. But if you can, just hop back up and hit enter and it'll put it right in there for you. And then you don't have to round. Okay, anyway, your B should be 42.2 degrees. So what does this tell us with the ambiguous case when we get our first angle? Tells us we got a triangle. We got ourselves a triangle. Okay, we have at least one. Fantastic. Okay, let's go ahead and finish this triangle 1, and then we'll test for a second one. Okay, so for angle C, I'm going to do 180 minus 70 minus 42.2. And that's going to give me that C is 67.8 degrees. Okay, there we go. All right, now I'm still going to need side C. Now, since I'm looking for a side, I'm going to use the law of sines, but I'm going to put the sides on top because that's what I'm solving for. Okay, I'm going to use the A because that is what was given to me. Okay, put side C on top, I'm solving for him, divided by sine of 67.8. That's going to give me a C of 6.90. Okay. All right, everybody okay with how we got that? We know there's at least one triangle. Okay, now let's check for a second. I'm going to check for my second triangle. here we go. Okay, let's remember our steps. First step, okay, is that we're going to take 180 minus the first angle we solved for. What was the first angle we solved for? B now, right? They changed. 42.2 degrees. Okay, let's see. That gives me 137.8 degrees. I'm going to call this B2, okay, just in case. All right. Now, here's the step that'll tell us, okay? Now, I'm going to take 180 minus the given angle. What angle was given this time? A, so minus 70. Minus this answer from step 1. Okay, when I do that, what do I come up with? Negative 27.8. So do I have myself a second triangle? No, because it's negative. Okay, so no, only one triangle. What tells you? Is that negative? Okay, remember, if that had come out to be positive, that would have been C2. And then we would have solved for side C2 using law of sines. Okay. All right. You have 3 word problems on this guy, on this section. I'm going to go ahead and record those for you, and I'll send you the recording so that you have it. And I'll tell you at what point you can fast forward in case you just want to get to the nitty gritty. But a couple of them are pretty tricky. You have to actually use, just so you're aware, law of sines and SOHCAHTOA. Once you get through law of sines, they're going to bring you into a right triangle situation. So you're going to want to have that too. Okay. And especially the last one, when you get to the Leaning Tower of Pisa, we get real weird. All right. Bye, guys. I will see you tomorrow where we finish our packets. Yay. Okay. For those on the recording, hang tight. We're going to let the herd of elephants leave. And then we're going to start on page. Okay. And we'll jump right in. Hey, Ab, can you turn the light on for me? Thank you, dear. You can leave the door shut. Okay. Here we go. Hey, guys, have a good day. Okay, so what we did with the ambiguous case brought us up to number 10 in my math lab. And I'm sorry it keeps going blurry on us. It's this camera. It's constantly in autofocus. Okay, so now that we're in word problems, this is going to be number 11, 12, and 13 because there's only 13 problems. So this is number 11. I'm going to try to keep him in focus for you. Okay, here we go. So this is, I don't know why that's being so weird. Okay, we're going to talk about a proposed ski lift. So what you're going to see in my math lab is this little ski lift. I forgot to copy it onto the packet for you, but this is a mountain, okay? And here's the bottom of the mountain, and they want to take people up the ski lift to the top of the mountain so they can ski down. Okay, so this is what we're dealing with. So let's just talk about it based on this picture. Okay, to find the length of the span of a proposed ski lift from P to Q. So this is the span, this is the side of a triangle that they're talking about because it's labeled P, R, Q. Okay, this is how it's labeled. Okay, so a surveyor measures angle DPQ and it's 25. So this little inner angle is 25 degrees. Then he walks back a distance of 1,000 feet to R. And he measures the angle from R to Q, this little angle right here, to be 15 degrees. He wants you to find the distance from P to Q. Okay, so let's draw the triangle that we're interested in. Okay, so we don't have to draw the whole ski lift here, but let's see. What we're really trying to find is this situation, this triangle. This is P, this is R, this is Q. Okay, we know that R is 15 degrees, 15 degrees. We know side Q is 1,000 feet. Okay, and that's all we know. Well, sorry, there is one more piece of information. we know that outside here, this little angle is 25 degrees. Okay, this is important because without him, we can't solve it. I can't solve a triangle with two pieces of information. I'm gonna need another piece of information. So if this angle is 25, I know this angle because remember, these are supplementary angles. And when I add them together, they add up to be 180. So if I'm trying to find angle P, he's going to be 180 minus 25 degrees, which equals 155 degrees, which makes sense because he's an obtuse angle, right? He's leaning back in his chair. Okay, that's also going to give me angle Q, because if I know these two angles, I can find the third angle. Angle Q is going to be 180 minus 155 minus 15. Angle Q is going to be a little bitty 10 degrees. There we go. All right, so I have all my angles and I have one side. What I'm looking for is the distance from P to Q, which is actually side R, right? That's what I'm looking for, is side R. Okay, so I'm looking for a side. I have all the information for Q and I have the angle for R. So if I'm looking for a side, I'm going to use Law of Sines and I'm going to use Q because I have all the info. And I'm going to solve for side R. So I'm going to have 1,000 over sine of 10 degrees equals R over the sine of 15 degrees. I'm going to multiply these together. Okay, multiply, divide by sine of 10 degrees. And my R is going to be 1,490.48 feet. And that is P to Q. We just happen to call it R in our triangle. Okay. All right, easy enough. Okay, now we get a little more complicated. 12 and 13 are not really easy problems whatsoever. Okay, so again, I didn't copy your little picture. I got to get on that. I'm so sorry. I put him in mine, but I didn't put him in anyone else's. Okay, so he's a little blurry, but here's the deal. You have an aircraft, an airplane, who is spotted by two people, two observers. Here's a person, here's a person. They're 1,000 feet apart. Okay, let's see if we can get this to focus a little more. There we go. They're 1,000 feet apart. Okay. The airplane passes over the line that's joining them, and each observer takes a sighting of the angle of elevation to the plane, which means this little angle. So we're making one giant triangle here, okay, with this one being 50 and this one being 25, and this side being 1,000. Okay, so let's draw that. Here we go. Here's our triangle. We have person P and person Q, and they are 1,000 feet apart. Here we have our airplane. I'm going to call that R. Okay. So here's side P, here's side Q, here's side R. We know this is 50 degrees, and we know this is 25 degrees. Okay. What we are trying to find is how high is the airplane. We're trying to find this measurement, this line straight down. Okay, well, first of all, in order to find this line straight down, that's going to be this triangle, right? That's like using this triangle, or you could use this one if you want to, but it's cutting this big triangle in half and showing that there's actually a right angle or a right triangle involved in it. Okay, so this would be P at 50 degrees, right? All right, and I don't know this side and I don't know this length because I can't just cut the 1,000 in half. I can't do that because they are not equal. How do I know that it's not completely cut in half? Is because these aren't the same. If these were the same, I could cut it in half, but I can't do that. Okay, so what I'm going to need to find, if I'm trying to find this side, is I'm going to need to find this side over here. If I could find Q, then I could do opposite over hypotenuse. I could take the sine of 50, because it's a right triangle, I can use SOHCAHTOA. So I want to come back over here to my giant triangle and I want to find Q. All right, well, let's see what I have here. First of all, I'm going to need to know one letter that has all the information. I have side R. If I knew angle R, I could use that. So to find angle R, I'm going to do 180 minus 50 minus 25. Turns out angle R is 105 degrees. Okay, now I'm going to use the law of sines. I have everything I need to know about R. So I'm going to use sine R. I'm solving for side Q, so it goes on top. Whoops, this is sine Q. Okay. All right, plug in what I know. So I'm going to have 1,000 over sine 105 equals Q over sine of 25. This is going to give me 1,000 times sine 25 divided by sine 105. This is going to give me a Q of 437.527. That's what Q is. 437.527. Now remember, I just cut this triangle. I made a right triangle and moved it over here. So that's also this side. Okay. All right. So now I have gotten all the information I can out of this oblique triangle, all of it that I need, by just cutting down the middle here and then taking this piece and moving it. Okay. I don't know this angle. I don't need it. I don't know this side. I don't need it, but I do know this side. So if I'm sitting here at 50 degrees, I need the opposite, and I do have the hypotenuse. So remember, SOHCAHTOA tells us sine is opposite over hypotenuse. And I can use that because I have a right triangle now. So here I go. I'm going to say the sine of 50 degrees equals opposite. Okay, I don't know that. So I guess I shouldn't have called this. I don't know what you want to call this. I don't know if you want to call him A or I don't know. I guess we could call it O for opposite, whatever. Anyway, there's the hypotenuse, which is 437.527. Then I'm just going to multiply those together. 437.527 times sine of 50. And then I suddenly have the height of the airplane, which is 335.17 feet. Okay, so this was tricky. We used law of sines, but then we also incorporated a right triangle into that. And so it worked out. Okay. All right, here we go. We have this one. Okay, so again, we don't have a picture here, but there is a picture. I just, again, forgot to give it to you. Okay, so we're talking about the Leaning Tower of Pisa, the famous Leaning Tower of Pisa. So this is a tower in Italy, okay, in the town of Pisa. That's why they call it the Tower of Pisa. And it was originally this many feet high, okay? And it is at a distance of 123 feet from its base. Okay, so this is 184.5. This is the base, okay? The angle of elevation here to the top of the tower is 60 degrees. Find angle RPQ in this figure. Okay, so we want to find angle P. That's what we're looking for, is angle P. Then we also want to find the perpendicular distance from R to PQ. Okay, so first of all, let's just find this angle P, this angle RPQ. Okay, so again, he's a leaning tower, so he's going to kind of be like this, right? He's not straight. He's not a right triangle. He's not the perpendicular tower of Pisa. Okay, so PQR, I'm just rewriting what I have. you're going to have a nice picture on my math lab. This is 60 degrees. It gives you this. So it gives you quite a bit of information, actually. There you go. All right, first thing it asks for is RPQ, or angle P. That's what we're solving for. Okay, well, this is a very straightforward law of sines because I have all the information for Q, okay? And I want P, but I can't solve for it yet because I don't have anything at all related to P. Okay, so I'm gonna have to figure some things out here first. If I use this to find, okay, angle R, I can find angle P. Now, I know this is an angle side-side case and normally would say, oh, that's the dirty word, that's the ambiguous case. But in a word problem, you don't have to worry about it. We definitely have a triangle, we saw the picture. And we only have one triangle because we saw the picture. So we don't have to worry about an ASS case when we have a word problem. We just solve for it. Okay, so based on what I have one choice and it's to solve for angle R. So I'm gonna put the angles in the top and I'm gonna solve for angle R. So I have sine of 60 degrees over 184.5 equals the sine of R over 123. Okay, now remember, you're gonna have to use inverse sine here. What you're gonna come up with is going to be the answer for sine R. It's not gonna be all of angle R. So I'm gonna do 123 times sine of 60 divided by 184.5. Okay, that's gonna give me this. Okay, let's just do that together on our calculator. So I'm gonna have 123 times the sine of 60 divided by 184.5. Okay, there's my answer. Now, that's for sine R. Now I'm going to do second sine, right? Because I'm going to have to take the inverse sine. And I can just pop right up here and hit enter and put that right into my inverse. And it turns out that my R is 35.26 degrees. Okay. All right, so that's my angle R, 35.26 degrees. Now remember, I'm trying to find P. Well, if I have two angles, I can certainly find the third using my law of triangles. Turns out angle P is 84.74 degrees. And there we go. Okay, perfect. Now, let's think about what else we have here. Okay, the next thing that it wants, here's where it gets a little confusing, and I see the word perpendicular, so I'm gonna have a right triangle involved. What it wants you to do is find the perpendicular distance from R down here to P. That's what it wants. It wants you to drop a line right down here and find that, okay? So if I drop a line down, I have this triangle that I can use or this triangle that I can use. And I can decide either way, whichever one it is that I would like to use. I would encourage you to use this one simply because it's the angle that was given. Now you don't have to, you can use this one. It's the angle that was given. It's actually going to be a little easier math for you, but that's the one I would encourage you to do just because it's good practice, because this is what was given, okay? So I'm trying to find this over here. This is 90 degrees, I know that, right? Now I need this. I need side P, and I never found side P. So I'm gonna use law of sines to find side P, because I'm gonna need a side. All right, so if I do that, then I'm gonna have, okay, I'm gonna keep my R's, and I'm gonna do R over sine R equals P over sine of 84.74, okay? Now again, you could have chosen this triangle instead and found this side. It's up to you. This is the side we're trying to find, okay? All right, so, oh, I should have put sine P here. I kind of messed that up. Okay, here we go. So little r is 123 Big R is the sine of 60 degrees. Okay. Is that right? No. What am I doing? I should have used Q. Q is what I'm supposed to be using. Sorry, guys. I got confused about what I was doing there. I wasn't looking on my paper. I just went out on my own, and that's what happens. Q over sine Q, because Q is what was given. Okay. All right, so Q is 184.5 over sine of 60. Trying to find side P. Okay, and then I have angle P, sine of 84.74 degrees. Okay, so I'm going to multiply these together and divide by the sine of 60. This is going to give me a side P equal to 212.15. So 212.15. Okay, so that's my hypotenuse. I'm sitting here again at 60 degrees, right? And I look over to here. Okay, this is my opposite, which is what I'm trying to find this opposite over here. And I have my hypotenuse. Okay, so I can use the fact that sine 60, SOHCAHTOA, is opposite over hypotenuse. Okay, and when I multiply these two together, A is going to give me 183.73 feet. And there we go. Now I just want to show you, what if you had used this other little triangle? What if you had used him instead? Well, here's your right angle. Should have drawn him bigger. Here's, okay, 84.74 degrees. Okay, I have this, it's 184.5, and then I need to find this. So I could have taken the sine of 84.74 equals opposite over hypotenuse. Okay, and then I could have done sine of 84.74 times 184.5. And again, there's my 183.72, close enough for my height. So you could have taken either triangle and they would have worked just fine. There was a little more work involved with this one over here, but either way, you get the same answer. Maybe just one decimal off, and it should take it either way. All right, so I will see you on Tuesday to finish our packet. We're now going to talk about the law of cosines, and then we will also look into finding the area of a triangle.